Okay, so I think the past 2 weeks our attendance has been pretty low. So I'll kind of slow down a little bit with that topic. But we're going to move on now to the next part. So I'm hoping that you have your notes out so that you can do work. Jamie, where's your sheet? Okay, cool. Get it out, please. All right. So we're doing this. All right. Thank you. So we're starting on volume. Now, last lesson and the ones before that, we looked a lot into surface area and area, okay? But with the surface area questions, we're looking into surface area of composite shapes. Yes, Sophie?
Can I get my sheet?
Yes. Okay, we're looking at surface area of your composite shape. So remember, surface area is all about finding the area outside of a 3D shape. Okay, so it could be like the area of this hand sanitizer, okay, or the area of this rectangular square prism looking thing, okay, which is sticky notes. But composite shapes involve more than one shape. So you might have, for example, here you've got a triangular prism and then a rectangular prism in the bottom. But remember with surface area, it's only the faces that are exposed. Okay, so the faces that you can see. You don't calculate the areas of faces. For example, in this triangular prism, Callum, I'm going to ask you, what is covered in this shape here? So you've got a triangular prism at the top and a rectangular prism in the bottom. If I put them together, something's being covered. What would it be? Well, that middle bit here, right? Yeah. You can't count the area underneath the triangle and above the rectangle because it's covered, so you don't include it. So you literally, if you visualize this, all you're calculating is the side and this side as well, this triangular face and that triangular face in the back, and then the rectangles that you can see. There's one in the back and then one over here that you can't see. Okay, so it's only the exposed area of the surface area that you're looking at. Now, the difference between that and what we're looking into now, which is volume, okay, is we're looking at the area or the space inside of a shape. Okay, so understand the difference that surface area is the area outside, volume is the space inside of a shape. Okay, so our intention is to try and solve volume problems that involve prisms, okay, and cylinders and composite solids. So remember, that word composite has appeared before. Composite just means two shapes put together. So now you're going to be looking at the volume of two shapes that have been put together. Okay, and by the end of today, I'm hoping that we can do all of this. So convert between units of volume, so between centimeters squared, centimeters cubed, meters cubed, but also going between meters cubed to liters. Okay, how do we now figure out if you've got the area of, for example, a fish tank, how much water can you fit in there? Okay, it's different. It's slightly different to meters squared and liters squared. So how do you convert between them two? Okay, you're also going to look into the volume of prisms. So these are, another word for prism is just a 3D shape. Okay, volumes of cylinders. Okay, and then the volumes of your composite solid. So all about volume for this lesson. Okay, we're not going to do some of these starter activities because it's there's a link that you need to look into. But basically, if you look at these shapes, okay, we've seen some of these before. You've calculated the surface area of a triangle prism. You've done the surface area of a rectangular prism, surface area of a cube. You've all done it. You've also done surface area of a cube with a hole in the middle, okay? Now, what's going to change here is instead, again, of finding the exposed area, so for example, this face and that face and this face and that face, okay? The difference is we're going to now find the area of the space inside the shape, the literal inside, okay? That's what volume is all about. So the shapes that you'll probably see most of are the triangular prism, rectangle, you might see a cube and this. You won't really work with these prisms, okay? They're not going to be included in any of the assessments that we do, okay? Or they shouldn't be, okay? All right, let's go to this page. What is volume? Sorry about this, by the way, it just printed the wrong way. What is volume? Okay, so volume is the amount of space. That's the key word there, the amount of space within. Okay, so the space within a shape, okay, or within a three-dimensional object. Okay, so it's the amount of space inside any three-dimensional object. Now, the space inside can be measured using these units. So now instead of squared, we have cubed. Okay, so centimeter, decimeter, and meter. I don't think we really use decimeters, so it only ranges between centimeter and meters, but we'll chuck that in there as well. And they can also be represented in milliliters or liters, because if you think about water or like any liquid, okay, a lot of them are measured obviously in milliliters and liters, not actually in cubic meters or cubic centimeters. I don't know if you guys know, but if you buy a fridge, they actually measure that in terms of cubic meters. Cubic liters. They don't say, oh, this fridge has a space of 2 square meters. They say, oh, this fridge can fit about 900 liters worth of food, which doesn't make sense, does it? But again, it's just the way that they actually use and convert meters into liters. That's why they call it that. Another thing they do is the space in your car, the boot of your car. Okay, believe it or not, they actually use, okay, volumetric. So when they say, oh, my boot is 900 liters big, okay, that's what they use to actually measure it. So it is referred to as your capacity, okay? Some things to look into as well, okay, if you're converting between units, okay, 1 cubic centimeter, okay, can be converted into 0.001 decimeters, or I think it's decimeters, and then these are meters cubed. I'll show you really quickly later how to convert these, okay? But this table I found is a little bit confusing, so we'll answer this question shortly, okay? But just understand volume, space within a 3D object, and these are the units that we use to now refer to. So don't use squared for volume, use cubed. Okay. So here's a way you can sort of visualize volume. Here is a, 10 centimeter by 10 centimeter by 10 centimeter shape, okay? And you've got the measurements here. Sorry, not 10 centimeters, 100 centimeters, because 100 centimeters equals 1 meter. Now, this meter, that meter, that meter, okay? All important numbers. Okay, and the reason why we're showing you this is because you need to figure out or see 3 numbers or have 3 numbers to figure out what the volume of any shape is. And you can see here, for example, one of these, okay, will fill up a small unit right there. And you can see that it is a 3D shape. Okay, so one of these, or each one of these represents a decimeter, which is, I think, 10 centimeters. Okay, but visualizing volume like that, you can see, okay, that is a 1 centimeter cube right there. Okay, I think this makes more sense as we go along. So let's keep going. Oh, actually, let's answer this. How do you convert between liters and meters and centimeters? And I think those are the only units. Okay, so when you have liters, this is how we convert them. Okay, milliliters, kiloliters, I think megaliters, kiloliters, liters, and mils. I've found that in the SAC, you're only really going to be focusing on these two, L and ml, so liters and milliliters. I haven't really seen many questions that have megaliters or kiloliters, okay? So we're just going to focus on these. But what you'll notice is these ones are a bit easier, okay? You're actually only going to be moving or multiplying or dividing by 1,000 each time. So it's not by 10, 100, or 1,000. It's just always 1,000 when it comes to volume. Okay, you're always converting by 1,000. So, for example, if I want to convert 32 megaliters into liters, okay, so megaliters to liters, I am multiplying by 1,000 2 times. Okay, so let's say I had, 4 megaliters, mg. Okay, I want to change it to liters. Okay, so that means it's going to be 4 times 1,000 times 1,000. Okay, so it's going to be 4 million liters. Okay, because it's times 1,000, and then times 1,000 again. Similarly, if you want to go from mils to kiloliters, okay, let's say you have like, I don't know, 200,000 ml, and you want to change it to kiloliters. Okay, notice how it's going to be divide by 1,000, divide by 1,000. Okay, so I'm going from ml to kl. So I'm dividing by 1,000 twice. So that's going to be 0.2 kiloliters. And you can just do this on your calculator, really straightforward. Okay, now the thing that's not included here that I would like you to write in there somewhere are these units here. So actually, no, these ones are in it, but we're going to look into this shortly. Okay, so cubic meters. How do you then move between different cubic meters? So from meters to decimeters or demimeters to centimeters and into millimeters. It's the same concept, yeah? It's going to be timesing by 1,000 or dividing by 1,000. It's all the same. But just be mindful that if you're going to convert between, and I actually didn't know this, but between meters squared or cubed to centimeters cubed, you're multiplying by 1,000 twice. I thought it was only once, but it's different to area. Okay, so just be mindful of that. Between meters cubed to centimeters cubed, times by 1,000 twice. And then vice versa, from centimeters cubed to meters cubed, it's divide by 1,000 twice. Okay, so just bear that in mind. Okay, bear that in mind. Now, the thing that isn't in here that I would like you to put in there is this, somewhere in there. I think if there's anything you need to know, these are the main ones. So if you want to move between liters, so your liters squared and your millimeters squared to like, your liters squared to like centimeters, you need to know this. Okay, so if you want to change from liters to millimeters, you know that's easy. To multiply by 1,000 or divide by 1,000. However, if you want to convert 1 centimeter, okay, into volume of like liters and milliliters, just know 1 centimeter cubed is the same as 1 milliliter. Okay, 1 centimeter cubed, same as 1 milliliter. Okay, 1 meter cubed is the same as 1,000 liters. Okay, so you're literally just multiplying. Actually, for centimeters, it's 1 for 1. It's the same thing. So, for example, if I had 20 centimeters cubed, how many mils would that be? 20 mils. If I had 100 centimeters cubed, 100 mils. Okay, but for meters squared or meters cubed, sorry, you're just multiplying by 1,000. So if you had 2 meters cubed, okay, if you times that by 1,000, that would give you 2,000 liters. Okay, if I had 4.5 meters cubed, times that by 1,000, and that would give you 4,500 liters. Okay, so you're literally just multiplying by 1,000 when it comes to changing meters cubed to liters. Okay, so just bear that in mind because you will come across it. I found maybe one question in the SAC where it just asks you to convert meters cubed to liters or centimeters cubed to milliliters. Okay, so just put that in there because I don't think they put that in there before. All right. Jacob, why are you asleep? Are you writing notes? I don't think you are. Okay, make sure you're writing notes, please. All right, let's continue on. So, finding the volume, okay, of most shapes is actually quite straightforward. Okay, if you look at these shapes, okay, you might think that there's different ways of finding the volumes of each one, but it's actually quite easy. Okay, for all of these shapes to find a volume, it's going to be length times width times height. Okay, so that's for any shape. When it comes to the area, especially these, length times width times height. So the formula won't change, okay? But your numbers might for most of these shapes. Length, width, height. So in this shape, might actually use colors for this, yeah? So let's go that and that. So for example, in this shape here, the length is 3. The width is 6. And the height is 10. So if you were to try and find the volume of it, length times width times height, okay, it'll be whatever it is. So in this case, it's going to be 3 times 6 times 10. Okay, which equals 180, whatever the units are. It doesn't say. Let's just say centimeters cubed. Now, the thing that you have to be mindful of is that with these shapes, so these are what you call obliques, what do we think this length is going to represent, that 10? Is that still going to be the height?
No.
No, okay? This 10 refers to this length here. The height of the shape is this length. Okay, so we don't quite know what it is, but be mindful, okay, that with any shape, just because it says 10 there, that does not mean that it's this height length, yeah? You need to normally see a shape that has a right angle of some sort, but it'll tell you that that's like, I don't know, 7 or something. This 10 refers to this. Now, I don't know what it is, but it could be that the height for each one of these, so this could be 8, and that height will be like 6 or something like that. Okay, it'll be different just because of the obliqueness of it. Yeah, you'll come across some questions like that, but just make sure you understand that that's not the height, that's the height. Okay, so obviously when you calculate these, it's all going to be different. Like for example, this length times width times height for this one, if we used 8 as an answer, it'd be 3 times 6 times 8, which is definitely less than that. And then similarly for this one, length times width times height. Okay, it'll be 3 by 6 by 6. Okay, it'll be different in terms of volume. All right, what are we up to? Let's do some of these examples here. So like I said, or like I mentioned before, for any shape, okay, you're going to be finding the volume, okay, based on that formula, length times width times height. Now, what you'll find here is this sort of simplifies it depending on the shape. To find the volume of most shapes, it's going to be the area of the face multiplied by the height. Okay, depending on the shape, for example, this is a circle. So the area of that base is going to be pi times radius squared multiplied by the height for the circle. Okay, so that'll be for that one. Whereas for this one, it'll be length times width times the height. Okay, so slightly different, but in essence, it's always about find the area, multiply by the height. Okay, find the area, multiply it by the height. That's the same for any shape that you work with. It's always going to be area and then times it by the height. All right, let's try and do some of these together. All right, let's calculate the area of these prisms. All right, so let's work on this. First one there is a parallelogram. Now, if you remember the area of a parallelogram, it's going to be base times the height. Really easy for any area of the parallelogram. Now, the way that this parallelogram works is we're going to find the area of this face and then multiply it by this height here. So what this is going to be for this parallelogram, oops. Okay, so the parallelogram volume will be base times the height multiplied by, now if I said h again, you'd probably get confused, but it's this, that's what I'm referring to. So let's just call that the width. Doesn't really matter what the name is, okay, but essentially, remember, you're trying to find the area of the face, and then you're going to multiply it by that number there. So this will be 7 times 3.5 times by the 8. So if I put that in my calculator, 7 times 3.5 times 8 equals 196. So the volume is 196 centimeter. Remember, we use cube now. We don't use squared for area anymore. Okay, for a cylinder volume. Okay, let's use another color. For this one, okay, again, it's the same principle. Just find the area of that face, okay, and then multiply it by whatever the height or length is. So, anyone remember the volume for cylinder, the area of a cylinder?
2 squared times pi.
2 squared times pi.
R squared.
Okay, cool, yeah. Or pi times radius squared. Same thing, yeah? And then you multiply that by the height, which is going to be that number there. Okay, so in this case, the volume is pi times 2 squared times 1.5. Okay, so pi times 2 squared multiplied by 1.5. So it's actually easier than doing surface area because you just have one really short formula for these questions. So we'll go 18.85. And we'll go centimeters cubed. Again, making sure, okay, that you label them as cubed and not squared. Okay. Claudette, are you writing any of this? Good, good, good. All right. So that's really easy. Most of the shapes you actually work with are just going to be like this. But every now and then you might come across what you'd call a composite volume. And this, again, is quite easy, okay, because you're just finding the volume of two shapes and then add them together. So let's do this for example. I have this bit. Okay, this one for example. Let's work out the top. Remember the cylinder volume is going to be pi times radius squared times height. Okay, and then the square volume down here is just going to be length times width times height to find the volume. So let's do them. Let's do the cylinder first. So it's going to be pi times, all right, let's have a look at this. I know that this length here is the same as this because of the two little lines that are there. So if this guy is 6, this must also be 6, which means that this diameter is 6. Now, if that's the diameter, what's my radius? 3. Okay, the half length. Okay, so it's pi times 3 squared times a height of 2. So pi times 3 squared times 2, which equals 56.55. We'll go centimeters cubed. Okay, we'll fix that up a bit. 56. Okay, so that's the first part, just the top. Easy. Second one, again, really easy. Length times width times the height. So there's only 3 numbers you're looking for. So if the length and the width are both 6, so 6 times 6, and the height is 2. Okay, 36 times 2 is 72. Yes. Okay, so it's 72 centimeters. Oops. Centimeters cubed. Right, so add them together. So the total volume. Okay, what's that? So just add them both together. 72 plus 56.55. So just add 72 to that equals 128.55 centimeters cubed. Right, so if you can do this for most of your shapes in this topic, when you do volume, it's actually quite easy. Okay, just trying to find the volume is, again, about find area of face, okay, and then multiply it by the height. That's for any shape you work with. Okay. A couple more things. Let's quickly work out some of these, and then we'll start working. All right. So for the volume of a sphere, so you might come across this, the volume of a sphere. Just use this formula right there. 4/3 times pi r to the power of 3. Okay, so just using that formula, 4/3 times pi times r to the power of 3. So for this example here, remember the volume is 4/3 times pi times radius to the power of 3 or cubed. So this is going to be 4/3 times pi times my radius is 7. So 7 to the power of 3. Okay, so calculator, you can go 4 on the top over 3 times pi times the radius of 3 to the power of 3. So that'll be 113.10.
Are you sure that's correct?
Why?
Are you sure you got the calculator?
Yeah, 4 over 3.
Isn't the radius 7 then?
Oh, sorry, where did I get 3 from?
Exactly.
Tripping out. I don't think I had lunch. No, I did. I had a big lunch. Okay. 1436.76. Thank you for calling me out on that one. Yes, I rounded it right. All right, easy. Just put numbers in your calculator. Easier than playing video games. All right, next one. Sorry, copying it along. I'll just zoom out a bit. Next one is volume of this. Okay, we've done that already.
Mr. This is definitely about centimeter cube.
Oh, thank you. Now this one is the same. It's just this one's a bit different. I don't think we're going to give you questions on this, and I don't want to confuse anybody. So we're going to skip that one, okay? Because it does use a bit of algebra, and I don't want to. Yeah, you guys are going to cry if I say that.
Yeah.
Let's just do this one, and then we'll start working. Okay, so we're going to find the volume of an ice cream cone. So here you've got a half a sphere on the top, and then a cone on the bottom. So keep in mind, if you're only finding the area, or the surface, the volume of a half of a sphere, what are you going to do with your answer?
Oh.
You got to divide it. So whatever this is, you have to divide it by 2. Okay? So, and then obviously the cone is pretty straightforward. Okay, just use the measurements that are there. All right. Oh, one more thing. What's the height of the cone?
Who said that? Yeah, you didn't.
That's all right. That's fine.
Yeah.
It's just here. I don't think this will actually be in the sack, but we're just going to do it because it's here.
That's 5 centimeters.
Okay. So, now looking at this, okay, you know that the height of the cone is 5. Okay, that's pretty easy. Okay, but the whole thing here, the whole ice cream is 7. So, what would this height be here? 2, good, which also corresponds to the radius. So the radius for this shape is going to be 2. So those are some things that you got to keep in mind. So that's 2 centimeters for the radius, all right? So let's calculate the volume. So this is going to be 4 over 3 times pi times a radius of 2 to the power of 3. Okay, that's the first one. 4 over 3 times pi times 2 to the power of 3 equals 33.51. So that's the top one. But, okay, bear in mind, because this is only half, what do we do?
Divided by 2.
Divide by 2. Okay, so divide this answer by 2 equals 16.76. Okay, so that's the volume of the top. Now we do the cone on the bottom. Just follow that formula. Okay, really easy. So it's pi times the radius that we got was 2 squared times the height, okay, of this cone is 5 over 3. Okay. Again, this might not be on the sack, but it's just good to know.
So would you find out the radius?
Where do I find the radius? Okay, have a look at the shape, yeah? This whole thing is 7 centimeters tall, yeah? The cone is only 5 centimeters tall. Therefore, the height of the dome is 2, which also is the same as the radius here, yeah? And that's why it's 2. Okay, so that'll be pi, I'll put in my calculator already. And I don't need to divide that by anything. Pi times 2 squared times 5 over 3, which is 20.94. Add them together. So plus 16.76. And that equals 37.7. So the total I forgot it already. 30.7. 37.7. Okay, there's the total volume. All right, any questions? Volume, I think, is probably a lot easier than surface area. Just find area of face, multiply it by the height. If you come across the sphere or the cone, just use those two formulas there. Okay, that's all it is. All right.